I'm using the _f_regression function from Sklearn, a powerful Python library for machine learning, to choose the best features for my regression model. This is an important step because including irrelevant features can confuse the model and hurt performance. I have a dataset with 5 features, x1, x2, x3, x4, and x5, that I think might help predict my target variable, y. I need to figure out which features are actually useful. These are the variables in my dataset. X1 through x5 are potential predictors or features, and y is what I want to predict. This is a statistical test that helps determine which features are most strongly related to the target variable. It computes an f-statistic and a p-value for each feature. The f-statistic measures how much variance each feature explains in the target variable, while the p-value tells us the probability of getting these results if there is no actual relationship. I've set my significance level to 0.05. This means I'll only consider a feature important if its p-value is less than 0.05, indicating less than a 5% chance of observing the relationship by random chance. Based on my analysis of the p-values, I've decided to include x1, x3, and x5 in my model and exclude x2 and x4, because they don't show a statistically significant relationship with the target variable at my chosen alpha level. Great job! I'm working with a dataset containing 5 features, x1, x2, x3, x4, x5, and a target variable, y. I'll use these features to predict the target variable using a regression model. I'm using Sklearn's fregression function. This statistical test helps me determine which features are most important for my regression model by assessing their relationship with the target variable. The fregression function gives me 2 key pieces of information for each feature. The f-statistic, which tells me how much variance in the target variable is explained by that feature, and the p-value, which tells me the probability of observing that f-statistic if there were no real relationship between the feature and the target. My goal is feature selection, choosing only the most important features for my model. This improves model performance and makes it easier to interpret. I've set a significance level, alpha, of 0.05. This means I'll only consider a feature important if there's less than a 5% chance that I'd see the results I got if there were actually no relationship between that feature and the target variable. Based on my analysis, features x1, x3, and x5 are important and I will use them in my regression model. I have decided to remove features x2 and x4 from my model because they are not statistically significant. I have a dataset with 5 features, x1, x2, x3, x4, x5, and a target variable, y. I'll use these to predict the target variable's value. I'm using the fregression function from the Sklearn library. This is a statistical test that helps me figure out which features are most important for my regression model. I've set my significance level, also called alpha, to 0.05. This means I'm willing to accept a 5% chance of being wrong when I decide a feature is important. It's a common threshold in statistics. Based on the results of the fregression test, I select the features. I'll only choose the features with a p-value less than my significance level, 0.05. I will use this dataset to build a regression model. The features, x1 to x5, are the input variables I will use to predict the target variable, y. I'm doing feature selection to improve my model by choosing only the most relevant features. fregression helps me do this. I only keep the features whose p-values are less than 0.05. Those features are statistically significant predictors of the target variable at my chosen significance level. This is the question I'm trying to answer by interpreting the results of my feature selection process. I need to evaluate different statements about my approach and findings. I'm using a dataset with 5 features, x1, x2, x3, x4, x5, and a target variable, y. I'll use this to practice feature selection. I've set my significance level, alpha, to 0.05. This means I'll only consider features with a p-value less than 0.05 as statistically significant. It's a common threshold in statistics. Think of it like this. I'm willing to accept a 5% chance of being wrong when I conclude a feature is important. This shows my features and target variable. Features are the different independent variables that predict the dependent variable, which is the target. Here, I'll summarize which features I'll keep based on whether their p-values were below the significance level of 0.05. Features with p-values under 0.05 are statistically significant and will remain. I'm using scikit-learn's _f_regression function to select the best features for my regression model. _f_regression calculates f statistics and p-values to help make this decision. It assesses how well each feature individually predicts the target variable. The output of _f_regression includes f statistics and p-values for each feature. The f statistic shows the ratio of variance explained by a feature to the variance not explained. A higher f statistic suggests a stronger relationship with the target variable. The p-value gives the probability of seeing the obtained f statistic, or more extreme results, if the feature and target were actually unrelated. I'm using the fregression function from scikit-learn to pick the best features for my regression model. This helps me build a better, more efficient model. I have a dataset with 5 features, x1 to x5, and one target variable, y, that I'm trying to predict. These are the variables in my dataset. x1 through x5 are my features, and y is what I want to predict. This is a statistical test in scikit-learn that helps me determine which features are most important for predicting y. It gives me an f statistic and a p-value for each feature. These are the results from the fregression test. The f statistic shows how much each feature explains the variation in y. The p-value tells me the probability that the observed result happened by chance. This is my threshold for deciding whether a feature is important. If the p-value is less than 0.05, I consider the feature statistically significant, meaning its effect on y is probably real, not due to chance. I'll select features based on their p-values. I'll only choose those where the p-value is less than my significance level, 0.05. Here, I'm applying my decision rule, selecting features only if their p-value is less than 0.05. This is a standard approach in statistical hypothesis testing. Based on my analysis, x1, x3, and x5 have p-values below 0.05, so I should keep them in my model. x2 and x4 have p-values above 0.05. Therefore, I should remove them from my model because they don't seem to be important predictors of y. That's not quite right. The f statistic shows how much variance in y is explained by each feature. While related to correlation, they are not the same. Correlation specifically measures linear association. Correct. A lower p-value means there's less chance that the observed relationship between the feature and the target variable is due to random chance, suggesting a stronger relationship. I'm working with a dataset containing 5 features, x1, x2, x3, x4, x5, and a target variable, y. I'll use this data to practice feature selection. I'm using scikit-learn's _f_regression function. This function helps me assess how strongly each feature relates to the target variable in a regression setting. It returns 2 key values for each feature, the f statistic and the p-value. The _f_regression function gives me an f statistic and a p-value for each feature. The f statistic shows how much variance in the target variable is explained by each feature. A higher f statistic suggests a stronger relationship. The p-value tells me the probability of seeing this f statistic if there's actually no relationship between the feature and target. A low p-value, typically below a threshold, like 0.05, implies the relationship is statistically significant. I've set my significance level, alpha, to 0.05. This means I'll only consider features with a p-value less than 0.05 as having a statistically significant relationship with the target variable. Think of it like a quality control check, making sure that my findings are not just due to random chance. Based on my chosen significance level of 0.05, I'll select features with a p-value less than 0.05 and discard those with a p-value greater than or equal to 0.05. After applying the 0.05 threshold, I selected features x1, x3, and x5 because their p-values are below the significance level. This question tests whether I understand the results of f_regression, particularly how to use the p-values to select important features. This statement is correct because each of these features had a p-value below 0.05. This is also correct. These features had p-values above my chosen threshold of 0.05. This is a true statement. A lower p-value means it's less likely that the observed relationship is due to chance. This table summarizes the f-statistic and p-value for each feature, providing the data I use to make my feature selection decisions. It's the key to solving the problem. This section introduces the core problem, using f_regression for feature selection in a regression problem. This section presents a multiple-choice question that evaluates my understanding of feature selection using f_regression. This statement is false. The f-statistic measures variance explained, which is related to but distinct from correlation. Correlation specifically describes linear relationships. I'm using a dataset with 5 features, x1, x2, x3, x4, x5, and a target variable, y. For feature selection using the fregression function in scikit-learn. I'll use this data to determine which features are most important in predicting the target variable. These are the 5 independent variables in my dataset, which I'll evaluate for their importance in predicting the target variable. Each feature might contribute differently to the target's prediction. This is the dependent variable, which I am trying to predict using a combination of my features. I'm looking for features which strongly influence its value. This is a scikit-learn function I'm using for feature selection. fregression uses an f-test to assess the relationship between each feature and the target variable. The result provides f-statistics and p-values. The fregression function outputs these values for each feature. The f-statistic measures the variance explained by a feature. The p-value tells me the probability of getting such a result if there's no relationship between the feature and target variable. After applying the fregression function, I obtain f-statistic and p-value for each feature. These results will help me decide which features to keep and which to discard for my model. I select the features with p-values less than my significance level of 0.05. These features demonstrate a statistically significant relationship with the target variable and will be included in my model. These features have p-values greater than 0.05, meaning their relationship with the target variable is not statistically significant at my chosen threshold. Therefore, they will be excluded from my model. I'm setting my significance level, alpha, to 0.05. This means I'll only consider features with a p-value below 0.05 as statistically significant. This is a common practice in hypothesis testing.